we're solving polynomial equations, and we're using the rational root theorem to come up with all the rational zeros. And so we know that we're trying to find P over Q. All the factors of A sub O is P. So A sub O is equal to 14. So all the possible factors for P are plus or minus 14, plus or minus 7, plus or minus 2, and plus or minus 1. And then our Q value is the lead coefficient. In this case, our lead coefficient is 1. So all the values are plus or minus 1. And so our possible solutions for this are P divided by Q, which ends up just being all the coefficients of our P value, because dividing by 1 won't change that. So plus or minus 14, plus or minus 7, plus or minus 2, and plus or minus 1. Okay, so now we're going to explore a little bit further. How does that help us? So if there is a rational zero for this polynomial, it has to be one of these values. And so we're going to check the values. I'm going to start with positive 1 and see what happens. So we're going to use synthetic substitution. Okay, so from synthetic substitution, I know that I'm going to check positive 1. So I want to check positive 1, and I'm going to use my coefficients, 1, negative 8, 5, and 14. So 1, negative 8, 5, and 14. So whenever we do synthetic substitution, we're going to add down and we're going to multiply on the diagonal. And so 1 plus 0 is 1. 1 times 1 is 1. Negative 8 plus 1 is negative 7. Negative 7 times 1 is negative 7. Add those down. 5 minus 7 is negative 2. And 1 times negative 2 is negative 2. And then we add down. 14 plus negative 2 is 12. Now, if this were 0, our remainder here should be 0. So our remainder is not 0. So 1 is not a root. Okay, so we know that 1 is not a root. Now we're going to check negative 1. So negative 1, we're going to do it the same way that we did. We're going to use our same coefficients. 1, negative 8, 5, and 14. And add down, multiplying the diagonal. So add down, we get 1. Negative 1 times 1 is negative 1. Add down, we get negative 9. We get positive 9. Add down, we get 14. Multiply, and we get negative 14. And now here, 14 plus negative 14 is 0. So our remainder in this case is 0. So negative 1 is going to be one of the roots. And so we remember that this is a remainder. This is our constant. This is our linear term, and this is our squared term. So we can rewrite our polynomial. We know that x minus 1 is a polynomial. So in the factored form, x minus 1 in factored form is actually x plus 1. So that is one of our factors. And we can continue to find the rest of our zeros. We know that x plus 1 is a factor, and then we have this left. So we have x squared minus 9x plus 14. So this is a quadratic in a quadratic form that we can factor. So x plus 1 comes down, and then we have to come up with our binomial that we can factor. And to help us out a little bit, if it's factorable, it has to be one of those values. Okay. So in this case, we need two numbers that multiply together to 14. So we're going to use 2 and 7. we know that two numbers that multiply to x squared are x and x, and they have to add to -7. So then we get -7 and -2. And then, because we know the zero product property, we know that we have, if we substitute -1, that makes it 0. If we substitute in 7, that makes this 0. If we substitute in 2, that makes that 0. So the zeros for this function are x equals -1, 2, and 7. And if we look over here, we have -1, we have +2, and we have +7. That came from the rational roots that we use to eliminate or narrow in our focus on what our possible zeros could be.